That's what we're looking for. So that light fluffy snow, you got to make a snowball. It doesn't always hold together, right? And then we get a little more water in that, or if the snow falls when it's a little moister, then we make a good snowball that all holds together well. The other thing that happens with snow, of course, is we have melting, freezing, so those snow crystals will actually kind of change to more like ice crystals. And so those also become quite a bit more dense. And that's what we have in the spring.
Does anybody here remember, we talked, I think, last time we were here, we talked
Interruption. This is just a reminder for all teachers to enter their attendance at this time. Thank you.
Last year when we were here for the 8th graders, right, we talked about the density and the ability of the snow to hold water. And we get to a point where the snow can't hold any water, we consider it right. Does anybody remember what the density of the snow would be when we consider the snowpack to be right, or it can't hold any more water if it was rain? Yeah, it's generally 35 to 40%. Yeah, generally if it gets to that, and the density is the water equivalent divided by the snow depth. That would be the density. So once it gets to 35 to 40%, we consider the snow right, meaning it cannot hold any more water. So if it was to rain on that snow and it was right, that rainwater would typically just run through it and run off and get melting, also melting snow. But early in the season, like Jim said, the snow is generally not right. It's very fluffy, and it has the capacity to absorb rainfall like a sponge.
Can you use the word saturated interchangeably with right, or is that really a different concept?
I guess you could say it's saturated. I would.
Yeah.
Yeah, you could say it's saturated. It's
40%.
40%.
Right, it can become super saturated. So it can hold a little bit.
I mean, I've seen densities up to 40 to 50%.
Pardon the
It
interruption.
depends if you got a lot of
This is just a quick
sleet.
announcement letting everyone
You know,
know
if
that
anybody
our
here
charging
skis,
meters
they talk about
JT is
corn
canceled
snow,
for today.
which is
So no
big
JT
crystals
with
of ice
Miss
like the
Medina
sleet cover or
today.
something.
Thank you.
So when you get a lot of sleet inside the snow, it may be higher than 40% in certain capacity. We use that 35 to 40% as a value.
So has anybody ever heard the term that there's dry snow and wet snow? Can anybody tell me the difference? Why would we use those terminology?
The wet snow has more water in it.
Right.
Typically sweeter than the lighter snow.
So if it has more water in it, is it more dense or less dense?
More dense?
More dense, right? So it's heavier, right? So those are the things. And another thing is when we get to it being right, that's a continual snowpack, right? It's not just one snowfall. And sleet is going to have, it's more closer to a wet snow. It has more water in it than it does, so it's not considered like a dry snow. So there's still frozen type of precipitation.
Does anybody remember why we do this? Why do we go out and measure this?
Let's see. Go ahead. And then,
To see if there's gonna be potential flooding
Right.
Right.
in the spring.
in the spring. Now, can we have some flooding before the spring? Can we have flooding in the middle of winter?
Guys, this should be an obvious response.
Go ahead. Are you gonna,
Yeah, I mean,
Yeah.
if it got like really hot for a little while.
can you speak up a little? I'm sorry.
If it got really hot for a while, then it could be flooding recently.
Flooding recently here, right? Now, was that just because of the melt, you think? Or were there other reasons too?
There was a lot of rain and
Right.
melting a lot.
So, And then part of the also flooding is what we call ice jam. So there's one here.
We had an ice jam here
In Freiburg.
and it closed the 113 up there. So what happens was you got a lot of runoff from the rain and melting snow. All that rain pouring down up on the White Mountains comes down through Jackson and Bartlett and into Conway and it makes its way down to Freiburg. And you get the water levels rise and you got all that ice on the river. It's all like sheet ice to begin with. And all that water underneath the ice rises, breaks the ice up, and it moves it downstream where the ice will get stuck on an island or a sandbar or a bridge abutment or a sharp end in the river, and that's exactly what happened up here near the Route 113 bridge, and it caused flooding in that all those big fields on the other side of the river. That was due to an ice jam and melting snow. So
there's some good videos online that I've seen recently. More and more cameras that are that they might do a kind of thing every 5 minutes is taking a picture, and I saw some incredible. They just took those time relief kind of all those photos, put them together, and showed these ice jams where the river is just sitting there and it rose 10 feet, and then it shows the whole ice jam and then drop back down again. The other thing that I thought was really neat to look at online was what they call frazzle ice in the rivers. The frazzle ice is actually, it's freezing, it gets super cool and it's freezing. The water is actually in rapid water. It's super cool and you get these little particles of ice that are flowing and they start touching one another. And immediately you have like slush buildup, and it can build up rapidly. And if you look for Frazzle Ice Yosemite Park, it's really incredible because this waterfall is coming down and it's getting super cool. And as it hits, it immediately is slush, and it just starts moving down. And there's these people in the park looking, and they're starting to back off, and you just see this. It's a bit like an ice jam. But you might like looking those up.
We had a lot of frazzle ice develop when we had our big cold snap, over 20, 30 degrees below zero. That frazzle ice, like Jim said, would form in areas where the water goes over rocks and imparts energy to the water, and that super cold water will freeze, and it flows downstream, and it gets stuck on bridge abutments, it gets stuck on sheet ice, underneath sheet ice. It can really pack up, and we get what's called freeze-up jams. And that happened early in the winter, and then the river will start to freeze over, and then you'll get the thermally grown ice on top of it, and then we have that big midwinter warm up in the rain, and then you get an ice jam. Actually, I don't know about you, but this is probably the worst I've seen ice in 20 years. Maine. I mean, there was ice jams from Maine all the way down to Pennsylvania, New York State, and even Connecticut, the lower end of the Connecticut River had ice jams. It was just absolutely amazing. And it was all because of that big cold snap we had from around Christmas to about the first week of January.
So 15 days.
15
Below
days.
freezing.
Below freezing in Portland. 7 days was never got about 15 degrees in Portland. So.
And the reason why I was thinking about that frazzle ice is I was at Wild River just on Tuesday, and all of the ice that had formed there had all broken up with that rain and all gone down toward the Androscoggin. And so we had open water, which normally when I go to that river, I walk right across it. I have to make holes in the ice to get a water sample. And the whole thing was open. So I took this ice chisel that I have to kind of like just check my way, and I started walking out. And I could see that there was frazzle ice slush going down. And as I took my metal bar and just held it in the water, it actually was starting to cling to that. And then I'm hitting the bottom. There was 8 inches of solid ice on the bottom, the entire bottom of the river, because it was all clinging to the rock. So, we think about it freezing from top down, but this was freezing as it was coming down because it got so cold after that rainstorm. So I hadn't seen anything like it. So these are kind of asides, but I think they're fascinating, and it's partly just what's going on this winter.
And one of the ice jams at Augusta on the Kennebec River, actually that peak on the Kennebec at Augusta was the third highest in history since 1936. It was almost, I think it was over 20 feet.
Are those cars still stuck there?
I think there's one car still stuck in Holloway.
Did you guys all see those images, the cars?
But if you look at the USGS website, I think you can still, you go back 7 days, I think, on your graph. But if you look at the USGS website, you can see how quickly the water rose in Augusta. It rose, I think it was 7, 8, 9 feet in about 2 hours, maybe 3 feet in 15 minutes. It rose extremely fast. If you have internet here, go to the USGS website.
Some of the people in Hollowell were kind of upset and disappointed because some of the parking areas are right down by the river, and that's where they parked their vehicles, and they never got the word or never heard that there was potential flooding. People in Augusta had heard that, they moved their cars. Hollowell, there were probably a dozen cars that got swamped. People were trying to get out there to their cars and hook them up and get them towed out, standing in water up to their waists. Anyway, why don't I quickly just say what it is we're going to be doing and what we're asking you to do, what you've agreed to do, and we appreciate it. And then you'll be getting us the numbers. This too is marked in inches, and so we're simply going to be driving this down into the snow. You can see that there are teeth on the bottom of this, and so if we do have icy conditions, or we might have the soft snow on top that we've just recently gotten, it might be a little crunchy underneath in places. So we try to get all the way down to the ground. We record the depth once it's in there, and then we carefully pull this up, and we want to make sure all the snow is still in there. Right? And what's interesting, Nikki was talking about that wet snow, or we were talking about some of the ripe or saturated snow. You might be pulling this out in the spring, and it will literally be dripping. The water's, it's holding water in that snowpack. But then we basically want to weigh this. And I forgot one thing. Can anybody tell me what I might have forgotten? Yep.
How much the tube was.
Excellent, thank you. Before we want to pull any of this snow up, we want to make sure, while this is empty, what this weighs. And we want to record that. Well, depending on which scale we use. We have some scales that we can, each time we weigh it, we can actually tell it 0. We tare, T-A-R-E, we tear it so that the tube empty. And so yeah, thank you, that's what we need to do first. When we get the snow, we bring it up. We have a full tube of snow, we want to make sure none falls out the other way, and then we weigh it full. And what we're doing is we're weighing in ounces, and because of the diameter of this tube, that's telling us inches of water, the equivalent. So we call that the water equivalent. What did I miss?
So, do you think we just do it once, or should we have to do it more than once? So we can get a good.
You have to do it like once a week so that it changes.
Okay. But when we go out to take the samples, we go outside, do we just put the tube in once? Or once? With a black sweatshirt?
I believe it's 10 times.
10 times? Alright. Anybody else? Is that correct? Okay.
I think you have to do it like why you have to do it a lot of times is because it's like the snow will change in places, so it may not all be the same, so you can get more than an average.
Right. Well, one thing is, yes, it's not completely uniform, so we want to take more than one. And another reason is, could we accidentally get a bad sample? Is that possible? Could we get a spot where there's actually a rock or something instead, and it not be the right depth? So we're going to make sure that we eliminate those too. So if we take 10 samples, how would we figure out one number at the end?
So we add the numbers up and then divide it by
Does anybody know what that's called? What process in math we would be doing?
Averaging?
Averaging, yes. So when I tell you you use math all the time, you really do.
I'm impressed how much you remember.
So how many groups do you have, when you do this once a week, do they all go out and do it, or do you have certain people assigned to certain?
Well, we've done it a little differently
It's
each year.
fluctuated every time. Yeah.
Sometimes we all go, but then I think last year you started picking out smaller groups.
Yeah.
And some of them were so trained, they could just go out and do it, very little supervision.
So the one thing you gotta remember is when you go out there, you don't wanna, I mean, if you all go out there, you don't wanna go out and
Spread out.
pollute your snow field, so to speak. You wanna take in snow that hasn't been disturbed. You wanna take the 10 readings in areas where you haven't taken the readings before. So generally, I mean, when I go out, I usually have snowshoes, but you can, in general, see your tracks where you are. You don't wanna take it in your previous tracks, or you wanna make sure you're taking these readings in the pristine snow that hasn't been disturbed. So, when we all go out there, we're gonna kind of
We want to kind of stay
in
together.
line, stay together.
Yeah.
Maybe we'll split up into groups, but you don't want to go traipsing around all through the area where you're going to be measuring snow. Otherwise, you won't have any places to sample the snow.
So when Tom and I go out, I call him as quick.
Yeah, so that's something we should point out. On the Tuesdays that you're out there getting readings, Tom and Nikki are also out, and they're going to a number of different sites, mostly in southern and coastal southern coastal.
Mostly York County.
York County. I'll be taking readings from Augusta. I head down east, and then I come back toward Augusta, and I go along the coast. We have readings from the power companies. They of course look at the snowpack as water and storage for their reservoirs. They know it's going to melt and eventually be in the reservoirs, so they've been recording snowpack. Geez, I think it started in 1910 or something.
Yeah.
Back in the early 1900s, so yeah, over 100 years, they've been getting snowpack readings and the water equivalency out there, because it's water and storage. It's going to end up in the reservoirs. Anyway, they're out there on Mondays and Tuesdays getting readings. Who else have we got? We've got
We have cooperative weather observers, so people that take volunteer observations at their house every single day
Yep.
of the year. They also will go out during those times and they'll do snow surveys on their properties.
Yep, so they go right in there.
Back in their
40s,
woods.
yeah, get their readings. We also hear from the Allagash Waterway. We hear from the Maine Forest Service up in the North Maine Woods. The rangers go out and get readings for us in different locations. So all of this information comes into us, and then we put up a map of the entire state, and you'll see all these points. And your point will be on there. Freiburg is on the map because of you all.
Do you need to look at New Hampshire data to help with the predictions, since Saco River is, the watershed is starting in New Hampshire, and does that impact flooding in Maine?
Yeah, thank you. We do have readings coming to us from New Hampshire, from who are they? The DES in New Hampshire, right? Department of Environmental Services. Is that what you?
Yeah,
Yes, yeah.
New Hampshire is the
Yeah, so if we just stopped at our borders in Maine, do you think we have anything that's along the borders? If we take out data points outside of that, we can't interpolate the information properly. So we need data points outside of it. So we also get data from Canada, so Quebec and New Brunswick, and the state of New Hampshire.
Do you get anything from Mount Washington?
No. Oh, we get them from the lakes. We get it from Harvard Cabin, which is actually owned by the University of Harvard, and Helmet Lake, which is owned by the Appalachian.
So they generate pretty high, because they're up over 3,000 feet.
So do the snow rangers go and get that from Hermit Lake?
They actually have people.
Or is it the caretaker?
The caretaker in Maine, so that's the only reason why they're not doing it in Maine.
The Caribou in their office, my equivalent to Caribou, but they do it.
And a couple of state agencies, the Maine Geological Survey. And then, so it's all called the Maine Cooperative Snow Survey. So you're all a part of the Maine Cooperative Snow Survey. And there's a website, and we'll be putting the maps up. And there are different maps. One map will show the depth throughout the state. Another one will show the water equivalency of that snowpack throughout the state. We have a map that shows the density.
The maps are gonna be a little more robust this year. aren't they?
Yeah.
Do they decide to go to the new website?
Yeah.
So I think you'll be able to go back and look at the history, right?
Yes.
You can look at 20 or 30 years and look at, of course you weren't doing it 20 or 30 years ago, but you'll be able to look at what the water equipment was like 20 or 30 years ago. It really, was that the main GS that did that?
Yeah.
Really, we've done the maps, and it was very interesting. But I want to thank you for doing, this is very important information for us for river forecasting. We use this data on a daily basis in the river models every day. The River Forecast Center in Taunton, Massachusetts, runs their river models to see how high the rivers are going to go or how low they're going to go. And this data is input in there. They have what they call a snow model within the river model. It's nested within the river model, and they determine how much of the snowpack is going to melt off. They look at temperature, dew point, wind speed is important. For instance, when we had that big meltdown, if you went over into New Hampshire, some of the higher terrain, like Whitefield, New Hampshire, Berlin, New Hampshire, they got to 62 degrees. They were up into the 60s, and dew points were as high as 62 degrees also. So, I mean, it was like putting a blowtorch on the snow with the high dew point and the high temperature and the strong south wind. So a lot of snow was melted in addition to the rainfall, and that's why the rivers came up and caused all the ice jamming that we had. So this information is very important to us, and we really appreciate you doing it. And we do use it for midwinter flood events like we had the other week. Actually, the models didn't do too bad. They were forecasting that the rivers would come up enough to break the ice up, and we actually issued flood watches a couple of days before the event, saying there was a possibility of ice jam flooding, and that was because of information like you give us and everybody that does the snow surveys. It's very helpful. If we didn't have this information, we would have no idea how much snow is on the ground. The model wouldn't know how much snow is melting. So it's very important information to us, and we appreciate it a lot.
And all those businesses and storefronts that are close to the river, and all those people that have parked their cars, those people that parked their cars in Hollowell and got flooded, they're all going to be watching the websites and looking closely at those flood forecasts, because they clear out. Sometimes in Hollowell, actually you'll see U-Hauls that are parked like up on the higher streets. They've come in and they've taken everything on the lower level and put all their stuff into a truck real quick overnight and gotten it up to higher ground. And then when the rivers drop back down, they bring the trucks back down. But it is useful information.
You guys have any questions?
The one other thing that we do too is in March we have the River Advisory Council. We have all the key partners, so Tom, Jim, the Maine GS Society, power companies. Sometimes the governor attends, or at least listens in, and we all get together in a meeting in Augusta and look at the current state of the ripeness of the snowpack to start to discuss of what could be the potential for the spring.
And that's going to be March 8th this year. I mean, you can dial into it. You guys
You guys can
dial
put it
in
up
and listen to it.
and listen to us.
I don't know if there's video with that. Jim, do you know if there's video with that? Are they
We should find out.
Yeah, we
I did it 2 years ago.
there was a video.
There was some, did you guys dial into it?
Yep.
Oh,
Yeah.
oh, good.
So we can ask to see, I mean, the state might, because we do presentations.
So the GS does a presentation, I do a presentation, our family office does one. The National Flood Insurance Program people do a presentation. We hear from Brookfield Power, the power companies, how high or low their reservoirs are. If they're above normal or below normal for the time of year.
And the Coast Guard are normally there.
Coast
Yeah,
Guard is
they
there.
break up ice on the Kennebec and,
But in that meeting, I like to hear from the Coast Guard if they are gonna come and break up the ice, and then find out when they're gonna come, because I sometimes like to go down and see their boats coming up the rivers, find out when they're gonna be there. The other thing I like is when Tom gives his forecast that goes out like a few weeks.
Yeah,
He gets
yeah.
his crystal ball and he tells us what's gonna happen for the rest of March and what the potential for flooding is. We all try to get him to go a little further out, you know. What's April gonna look like?
Sometimes the crystal ball is a little cloudy, and sometimes it's fairly clear. But yeah, we do that, we discuss what the possibility for springtime flooding is.
and then Tom also, writes a spring outlook every week,
2 weeks.
every 2 weeks.
I wrote one yesterday.
Yeah, and, that'll continue all the way until we're done with spring flood season. And so the information you also take, you guys are putting in that, is put into that also. We're gonna have to decide if we're gonna flood or not, or we think we're gonna flood.
Do you have any questions for us?
Yeah. So everybody knows what they're doing, right?
So we go home,
We're all gonna go out, we're gonna take some samples.
we,
I assume we're going out and take samples, right?
yep, we ready to go outside?
So is this the first one you've taken this year?
Yes, we have not done it yet this year.
Which is a good thing. I don't think that first, we did one so far this winter. It was on January 3rd, and it was cold.
That the
It was
first
just
thing
so
back.
cold to be out there. I mean, I have some mittens that I really like when it's that cold. And so I'm trying to write my notes and everything. It was just, it was brutal.
But one other thing, when you go outside, especially when it's cold, you probably want to let this tube acclimate to the temperature. I mean, it's aluminum, so it'll chill off pretty quickly. But if you go out really quickly and plunge it into the snow too quick when it hasn't had a chance to cool off, you may get snow melting inside here. You'll get ice in here, and you'll have a problem getting a good sample. And then when you take the snow out, you'll look in here, you'll see all kinds of snow stuck in there, and then you may have to put your hands on the tube to melt the snow out to get it out of here, and then let it cool down again. Of course, doing this will make your hands really cold. Probably in the time it takes to walk out there, it'll cool off. The tube will cool off. It's aluminum, so it conducts the heat and cold very quickly. So.
That's why it's also important to do the initial weight every time too. Because you did not get all the snow out of the tube.
Yeah,
So you know
that's
what
a good
your
point.
original tear weight
If you do take the snow out, and you notice there's snow in there or ice around the side, and you can't get it out, then you're going to need to weigh the tube again because it may be a bit different than the original weight when there was nothing in there. So, just so that we have it as accurate as possible.
So one thing we've noticed, and I'll just make a point, we can figure this out when we get out there, but on these spring scales, there's a spring in there and it pulls, and you can see the values as this gets pulled out. We just want to make sure that we're beyond this bottom notch, which is 0. Otherwise, we're kind of in the negative. We have to be either 0 or above for our empty tube weight. And so,
Why do you think that is? Why do you guys think that we need to be at 0 or above? What would be if we're in the negative? Do you think the scale would work right? So we need to scale to work right? So that's why that's important.
but this one with the these are actually nice when you get icy conditions. Sometimes you need to kind of twist this a little bit. But with this extra weight, these spring scales seem to work pretty well. You'll definitely be above 0. And we'll just note that value as the empty tube reading, the tear weight. And with these digital scales, you'll actually be able to, I think it says right on here, yeah, it says you'll be able to tear that, it says right on it, so that the empty tube, you actually make it go to 0, and then you can weigh it when it's got the snow in it. Does that make sense? I'm ready. The sun is out.